Right. We this was part of our last lecture, wasn't it? Limiting factors. And I sort of said to you that the whole thing about limiting factors was that you didn't have enough, but you could always discuss, or sorry, find out and analyze whether or not you had enough by simply looking at demand. Looking at demand. So in this question here, if we look here, let's look at material, for example. So this is what you need of material per to make 1 unit of this thing, and this is the amount of this is the demand for the product L, and same thing here. This is the number of liters you need, and this is the demand. So let us look at the total demand. Sorry, what you need, so to speak, if you were going to fulfill both contracts, so to speak. So for materials, you will need £3.25 liters per unit times 6,000 liters, and you'd also need £4.75 times 8,000 liters. So so you have £3.25 times 6,000, which is 19,500. 19,500, and you'd also need £4.75 times 8,000, which is 38,000. So when you add these two together, 38,000 plus 19,500, you have 57,500. So you have 57,500 liters is what you need. You only have 50,000. So material definitely is a limiting factor. So it's either, well, we know it's a limiting factor. It might be that, or it might be that. Now let's look at the product. Let's look here in terms of labor. Forgive me. If we look at labor, we see that labor, we need 5 hours of labor for each of these units. So for labor, what we have is a scenario where we have 5 hours times the 6,000 and 4 times the 8,000. So for labor, we have 30,000 hours that we need for product L, and we have 32,000 hours that we need for product M. So we have a total of 62,000 hours that we need. So it looks as though we need more than we have. So it seems that both material and labor are limiting factors. 64. So the key point, what we're trying to do here all the time, is to find what the contribution is per unit. Find the contribution per unit, and if we do that, then and the other thing to remember is that I've said several times is that our aim here is to ignore these fixed overheads. Our aim is to ignore these fixed overheads in the short term. This doesn't help our decision making in the short term. So what are we doing? If you look at the sales revenue, here you are. Here's your sales revenue here. We will, of course, if you like, divide this revenue by the bars sold by 75,000. Here, just to find the revenue, first of all, 300,000 divided by the number of bars sold. So let's do that very quickly. We have 225,000 divided by 75,000, which is £3. So we're selling at £3. Then we have the 300,000 divided by 125,000, which is £2.40. Right, and so we have these selling prices here. Now, in terms of variable costs, we have given to us here material, labor, and variable overheads. And so in terms of materials, if you're making 75,000 and your material is 30,000, we're literally doing exactly the same thing. 30,000 divided by the 75,000. So let's just do that very quickly. 30,000 divided by the 75,000, which is equal to 40p. Yes, we have 40p here. Direct labor is the 18,000 divided by the 75,000, which is 24p. And then finally we have the 22,500 divided by the 75,000, and that's 30p. And then we move on here, and we have the materials here. We have 62,500 divided by the 125,000 bars, which is 50p. And then we have the direct labor, which is 35,000 divided by the 125,000 bars, which is 28p. And then finally, we have the variable overheads of 47,500 divided by the 125,000, which is 38p. Right, so what we can now find is the contribution per unit, which is the difference between the selling price and all these variable costs. So for the apple, we have 3 minus 40p minus the 24p minus the 30p. And so we have a contribution of £2.06. And here we have £2.40 minus the 50p minus the 28p minus the 38p. And that is £1.24. Right, we know the number of bars. So we're selling here 75,000 bars. We're just, I'm just copying the top. So hopefully you're used to this whole tabular format of just going in and picking out the numbers on your 25. And so we can find total contribution. Total contribution, of course, is just the multiplication of the number of bars times their contribution. So you have £2.06. £2.06 times 75,000, which is 154. Just change my pen color. 154,500. And here we have the contribution per unit, which is £1.24 times 125,000, which is 155,000. Right, so let's add those two together. 154,500, which is 309,500. Take away the fixed cost. We have a fixed overhead of 150,000, and then we have 150,000, and then we have a budgeted profit of 159,500. So that's the first step, if you like, towards this process. That's the first step towards this process. So let's carry on cautiously. So now we have a contribution per unit of £2.06, and we have here a contribution here of £1.24. Now the question we want to ask ourselves is how much, in terms of how many hours do we need to make a unit, really. You can see this is all per unit. Now we know that we need 30,000 hours to make 75,000 bars. And so therefore to make one bar, we must need 75,000 divided by 30,000. So we need to make 75,000 to make is equal to 30,000 hours, if you like, to make 75,000 units. And so therefore, forgive me, to make one unit, we need 30,000 over 75,000. 30,000 divided by 75,000, which is 0.4 hours. So we need 0.4 hours to make a bar. And in the same vein here, we have 125,000 bars being made with 20,000 machine hours, and therefore to make one banana bar, we need 20 over 125,000. We need 20,000 divided by 125,000. And that is 0.16. So we need 0.16 machine hours here and 0.4 machine hours, right? So 0.4 machine hours here and 0.16 machine hours. So the contribution per machine hour, of course, is the 2.06 divided by 0.4, which is £5.15. And here it is 1.24 divided by 0.16, and here it is £7.75, which means that we have a higher contribution per machine hour with the banana bars, one, and then with the apple bars. Well, let's see how many what the situation is. We have only 35,000 machine hours available. So we have 35,000 machine hours available. And so therefore, we're going to make, if you like, our banana bars first because we have a higher ranking here, right? Really, that's really the case. So because it tells us clearly that we only have 35,000 machine hours available there. Okay, great. So let's look at this. So if you only have 35,000 hours, I suppose the question here is really how many hours do you need to make your bananas? And so if you were to fulfill the demand, I guess that's the question is you have to go back to see what is the demand for how many, if you like, how many bars are we trying to make? We're trying to make 125,000 bars. So we need 20,000 hours. Here we are, 20,000. So you have 20,000. So you make those 20,000. So you know that what you know is that you have 20,000 hours is what you will do here. And then you will have product A, the balance of 15,000 hours. That's sort of the point, isn't it? So you have 20,000 hours here. I imagine that's what this part of the table is, and 15,000 hours here. So we will make all the bars here, and all the bars here are, we will make the 125,000 bars. We will make the 125,000 bars here. Yes. So the question here is, I suppose, if you have 0.4 machine hours, machine hours to make one bar, and you have 15,000 hours, then to make, I guess the question is, how many bars can you make with 15,000 hours? If it takes 0.4 hours to make one bar, it must be 15,000. 15,000 divided by 0.4, which is 37,500. So you can make 37,500 bars of apple bar. You know what the contribution is per unit, so multiply the 125 times the 1.24. Yes, 125,000 times 1.24, and your answer is 155,000. And then you also know what your total contribution is here. You have 37,500 times £2.06, and that's 77,250. And so your total contribution, of course, is 232,250. Your fixed costs here given to us. Your fixed costs, I'm just looking for that. Yes, here we are. Your fixed overheads are 150,000. Fixed costs are 150,000 given to us, and therefore your profit, if you like, is the 232,250 minus the 150,000, which gives you 82,250. Yes. And that's 64. Slightly a big question. What I'm hoping is that we see something similar here. Yeah, you do have something very, very similar here in question 65. I don't know how similar, but it seems that 65 and 66 might be the ones that are no similar. They're all quite different. It's the process. So we will do them. We will do them as we go along. We'll I suspect what I suspect is that they're the same idea, but we'll just do them as we go along. So the next one we should do is we've just done 64. So let's go ahead and do 65 and do 65. Okay, right. So what do we have here? What do we have here? We're given these figures here in terms of the contribution and the units and the machine hours required. So we can, first of all, find the contribution per unit. And the contribution, we have a contribution here, we have the number of units produced, and therefore the contribution per unit is the contribution divided by the number of units, right? Because we can do that. And if we have the total number of hours required for this contribution, we can also find the contribution per machine hour. We can do that. So this here, the contribution per unit, is the 20,000 divided by the 80,000, and here it is the 24,500 divided by the 70,000. Okay, so what do we have here? 20,000 divided by the 80,000. 20,000 divided by the 80,000. So we have here 0.25 here, and here we have here 24,500 divided by 70,000, and here we have 0.35, don't we? Now let's look at the contribution per machine hour contribution. So that's the number of hours required to get you this contribution. So 40,000 hours to get. So therefore, the contribution per machine hour is just the 20,000 divided by the 20,000 over the 40,000. In this question is for squeakers, and for here it's the 17,500. So what do we have here? This is 0.5, obviously. This is 50p, and here what we have here is 24,500 divided by 17,500, which takes us to £1.40. £1.40. So just changing my color just because it means this gives us a higher contribution per machine hour, so that's the ranking. So we're told that you only have 50,000 hours of machine time. So you're going to make Hooters first. And you need 17,500 hours, so give them that, and the balance, of course, which would be 32,500. Balance of 32,500, therefore going to squeakers. So you'll make all the units of Hooters, and that's 70,000 units, yes, because you have all the hours available to make them, yes. Squeakers, because you know that you have 32,500 hours available, it takes, I think what we want to check, it takes 0.5 hours to make one of the units of squeakers. We know that, right? There it is, 0.5. We worked that out, 20 over, and actually, sorry, forgive me, let me just be very clear about that. Machine hours required, yes, to make each, sorry, these are my units. So you need 40 contribution per machine hour. Yes, that's what I did over here. So you need 40,000 hours to make 80,000 units. So therefore, to make one unit, you need half an hour. You need 0.5 hours. And if you need 0.5 hours and you have 32,500 hours, that means you can make 32,500 over 0.5. Yes, 32,500 divided by 0.5. And that's 65. So you can make 65,000 units. You can make 65,000 units. Yes, and that's what you can do. So let's get our total contribution. You have contribution per unit here, and that's 70,000 times 0.35. 70,000 times 0.35. That's 24,500. 24,500. And here you've made 65,000 units. 65,000 units times your contribution times 0.25. And here you have 16,250. And so we can get our total contribution, 24,500, which is 40,750. The total fixed cost is given to us. Total fixed cost is given to us here. Total fixed cost, where is that? Total fixed cost here. Here we are. You have 7 and 8. So these are fixed costs. They are not going anywhere. You have to pay them 15,000. They are irrelevant per unit. So it's 15,000. We add those together. And then you have your profit, forecast profit of minus that. And that's 25,000. That's 25,750. Right, that's that. So, I mean, we're really just sort of confirming. So Hooters should be the product made first, as it has the ironically it has the higher contribution. It had the higher contribution per unit, and it also had the well, I mean, it also had the higher contribution per machine hour. You know, it had the highest contribution. It had the highest contribution per machine hour. It had both. It had both, didn't it? We can see it here clearly. Yeah. I'm just trying to see if there's anything we've missed here with this question. Because I think following what they wanted here, they gave us contribution and they wanted us to, we could find what we needed from here, the contribution per machine hour, literally by comparing the contribution and the machine hours. And that's what we did. We did here. Yes, contribution per machine hour and contribution per unit. And we did that. Although I think we could have also in another context, have found how long it takes to find this, and then, but they did that all of that up here. Okay, great stuff. And that is question 65. Let's move on to 66. Okay, and we'll finish this series of questions on 66 because I've been looking at 67 and it looks literally similar to all the others we've done in every capacity. So we will do 66 just to kind of cover that sort of roundness of, or sort of circle of what you could get, if you like, by looking carefully at the information given to you. So you have some information here. You're given total contribution and you're given the number of packs to be sold. So we can find, if you like, the contribution per pack, which is literally this 26,400 divided by 6,600, if you like, right? So let's do that. So we have 26,400 divided by 6,600. It's 4. You have that here, and that's 4. And then we have here the 34,600 divided by the 6,920, which is 5. Yes, and here you have the 48,204 divided by the 16,068, which is 3. So we can clearly see the different scenarios here. That's fine. Great. First thing. Then we now have we now are told that we need, if you like, this number of plant extract required for this number of packs. So I suppose we can find, if you like, the amount of kilograms per pack, which would be dividing this by this. Yes. So 2640 divided by 6600, which is 0.4. So we have 0.4 here, and then I have the same thing here, 1730 divided by 6920, which is 0.25, 0.25. And then finally, we have 8034 divided by 16068, which is a half. Yes, and that's a half. And that's what we have. Okay, cool. And then what we then have, of course, is the contribution per kilogram, which is just literally because this is what is scarce, isn't it? And so we now have 4 divided by 0.4, 4 divided by 0.4, which is 10, of course. We now have 5 divided by 0.25, which is 20. And we now have 3 divided by 0.5, which is 6. Yes. And so of course we can now rank this. We can now do the ranking of this, of course. We have 1, we have 2, we have 3. We know how much plant extract we have available. I think we're told earlier on. Why have I got 6,000 in my head? Yes, here we are. You only have 6,000 kilograms of plant extract. So you have 6,000 only. So of course we're going to do this one first. We're going to give 1730 here. Then we're going to give 2640 here. Then whatever's left we will give to EF3. Yeah? So let's do that. So we have 6,000 minus the 2640 minus the 1730, which is 1630. So we have 1630 here. So in terms of number of packs that we can make all of A and B and C, D too. Yes, we can do that. We can do that. We can make here. We can make 6920 packs, and here we can make 6,600 packs. The question here is, I suppose, how many packs can we make? So, given that we need, you need 0.5 extracts will get you a pack. If you have 1630 divided by 0.5, that's how the number of packs you can make. You can make 3,260 packs here. 3,260 packs. Okay, great. So the contribution per pack now is us just literally multiplying this contribution per pack times the number of packs that you can actually produce. So let's just do that. So we have 6,600 times 4, which is a 26,400. And then you have your 6920 times 5. 6920 times 5. And that's the 34,600. And then finally you have the 3260 times 3, which is 9780. So let's find the total contribution. 34,600 plus 26,400. You have a total contribution of 70,780. And the fixed costs in front of us, let's look at what our fixed costs are. Yes, I mean, this is the total fixed cost, however you decide to talk about it. Remember, 30,780. 30,780. That's a nice one. Straight away into a 40,000 situation. And as I was saying, 67 really does look like the others. It literally is a repeat. So you literally just have to review the other ones we've been doing, and you will be able to manage that and work through that. It literally is a copy of, I think, 60, not 66. I think it's this one. Yes, this table looks exact. Is it? Yes, this table looks exactly like this one. Yeah, this one, exactly the same thing. Okay, and that brings us to the end of this series of questions in this video.